right. So yeah, our next speaker is Mohammed El-Beltagy, and he's giving a talk for us on Julia web server deployment, I think with Heroku especially. So.
Thank you, everybody. So I'm going to start my presentation. First of all, I just want to get like a show of hands. How many of you guys in the room have used Heroku at any point or the other? Okay, so we got quite a few. How many of you did like a Julia web deployment of any sort, maybe on AWS? Okay, excellent. Okay, so I'm going to get started. Just to kind of like give credit, this work was done by my colleague, Amgad. Unfortunately, he couldn't be here today, so I'm presenting on his behalf. We're going to be talking about our build pack, the issues that we face with it, and like our solution, and the results. And maybe if there's a little bit of time, we can do like a little bit of a demo. So the question is, why do we use build pack? Heroku is like fantastic if you want to deploy, push code out in the cloud really quick. It's got like fantastic tools. We write a lot of Julia kind of like little microservers, and we need to do that quite fast. And we don't think there's like an easy or seamless way to deploy these servers at the moment. And this is why I kind of like really dug into this and tried to figure out how we can do it in an effective way. We're not the first to kind of like attempt this. I think quite a few people have tried that before. This quotation is from a Medium blog post that was out in April. I don't know if Mark is here, but basically people have tried and they couldn't get it to work. And the problem has to do with it has to do primarily with the limitations of how you can boot up your Heroku instance. I'll get more into that later. So far, I mean, all the successful deployments we hear of, at any scale have been focused primarily on using AWS, which works, but it's number one, it's time consuming, it's not easy, and it costs money if you want to kind of like test out like a few things. Heroku, on the other hand, is like great. It allows you to kind of like manage HTTPS and scale. I mean, anything you can do with Heroku, you can do with AWS, just a little bit more effort. So it's a convenience thing more than anything else. So the issues that are you face when you're trying to deploy Julia on Heroku are fundamentally the biggest showstopper is that when your instance, or like what in the Heroku world called the dyno is booting up, it only has like a 60-second window. In that 60-second, your server should be up and running and should be listening on a port that that the Heroku has assigned to your service. So if it's not listening on that port within that 60 seconds, it just kills you, and it just kills the whole thing, and you can't do anything about it. So I mean, and so with Julia, the trouble is always like when you have packages, you have lots of packages. For example, say Flux, you want to do a little bit of like neural network or whatever. It takes a while for the package on the first run to actually compile, and that's the problem. And you might think, okay, but that's fine. The second time I'm going to say using Flux, for example, is going to run a lot faster. That's not the case in Heroku because all of these instances are atomic. You cannot actually write anything. You cannot write a persistent. You cannot do any kind of like persistent modifications of your instance. So all the code that goes in there has to stay in there. So that's a problem. So basically, each time it boots up, it's like a fresh copy. It gets its own it downloads like. The Julia executable, and it runs your code, and it does that. And if you can't get things done in a 60-second time window, you're toast. So our solution was basically to do the pre-compilation of packages during the deploy time. So deploy time is separate from the boot time. So when you push out code to Heroku, it does like a deployment, and that's what we've done. So we look into your we find the project and the dependencies and precompile them by looking into your project.toml and manifest.toml. And we build them all. And then what we do is that we exploit something in Julia, which are called concrete dependencies. You know, like, for example, how in Julia, in a fresh install, if you use, for example, using linear algebra, it never precompiles. It's already like precompiled. It's like part of the Julia kind of like core. So this is, we kind of like use a trick in which we push those packages in Julia in a way that kind of like it appears as if they're kind of like part of those kind of like concrete dependencies that will never be compiled. And when we do that, things really kind of like go quite fast. So pre-compilation is done. Runtime, we do this, and boot time goes down from 2 minutes to like 5 seconds, and it works. And also the other thing is that it's not about this boot time. You know, the servers are a lot more responsive as well. Second time you run them and so on. So now you can deploy Julia servers with just a git commit, and you can do it absolutely for free. Now, if you have a little bit of time, I can do like a quick demo. So you can actually, it's like, a few lines of code. The first thing you do is you can like git clone our repository. You can then do, after you clone, you have to cd, and then you do the Heroku. You create this Heroku instance. And then you simply, when you do that, it creates a Git remote for you. And then you can push stuff there. And when you do that, it's pushing your code now onto Heroku. And while doing that, it's going to go through the whole build process. And that's all there is to it. So I think I'm going to take questions here. And maybe I'll stop at this point. Thank you.
I have a question. Have you tested any of this stuff with, or is there any compatibility at all with some of the self-hosted Heroku-like things like Doku?
We never tested it with Doku, so
okay.
we would love to. Yes.
Okay,
haven't
thank
tried
you.
That yet.
Are you building a new system image to get the pre-compilation time down? Is that what you mean with the concrete dependencies, or?
No, we're just. I mean, I can show you the script. All what we do is that we just. I can show it to you here. Let me show you. It's quite simple. Just have to exit this. Sorry. Yeah, here we are. It's actually like a really, really neat, simple trick. So all what we do is basically we push this in your kind of like startup. We force like a compile, and then we push this into the base. We have this in your startup. We have this command-based concrete dependencies, and it will contain your package ID. And that, so basically when we're deploying, what we do is that we precompile and then make it sort of like part of these concrete dependencies. Okay. This is something that we discovered by digging into how Julia, for example, runs like linear algebra. It's not something that's documented. So we kind of like really dug into how does Julia quickly kind of like have all these libraries that are just there and they don't need to compile. So we're using the same trick.
Okay, thanks.
Yes. Okay. Any more questions? Okay, thank you.